founders of Tesora. I think I've known Ken. Did we meet about a year ago or so?
Something like that, yep.
And his company does database as a service. A lot of it is in open source with OpenStack. But I told Ken not to obsess over OpenStack, like all OpenStack presentations. Instead, spend more time talking about database as a service and everything. And if you have questions, we'll just interrupt you. Is that okay?
That'd be great.
Okay.
Although I won't be able to see hands being raised, so you'll have to just shout real loud.
Okay, we can do that.
Awesome. Great. So should I just, the sound's okay? I should just go ahead and get started?
Is everyone here okay?
Yep.
Yeah, you're good. And there's like 8,000 people in here. It's one of Boise's largest meetups ever. Hey.
I have a question. Let's see.
You have a question?
Already. Is that Ken's Corvette?
Ken, is that your car?
Yes, it is. It's a 1959 Corvette.
Sweet.
Yes.
Got that clarified.
The most important thing. Ever.
Thank you.
Sure. So anyway, I'll go ahead and get started. So yeah, I will try to keep this kind of OpenStack agnostic, but I do have a tendency to drift down the open source brick road. So I will apologize for that and just try to pull me out if I seem to be going into the weeds. So. And I'll try to focus on the cloud stack. And who am I? I'm the owner of that 59 Corvette, but beyond that, maybe that's the important thing, but I'm the founder and CEO of Tesora. We are the #1 contributors to the Trove project, which is the OpenStack project for database as a service. We got started on the path with OpenStack and with Trove in particular. We launched Tesora February of last year, so a little bit more than a year now that we've been on this path. We had previously actually been working on another project, the database virtualization engine, which was scale out and transparent sharding for MySQL. But we found that people were really looking for and the focus there was really around database as a service as well, with the idea of having a multi-tenanted scale out solution to deliver MySQL as a service. But what we found is that a lot of people were looking for more databases than just MySQL, and that and while that was a pretty interesting and innovative solution, people were also looking for kind of the basics, even just basic provisioning, which is one of the big things that Trove gives you is basic provisioning and management, whereas that was kind of more just on the scale out and multi-tenancy and really optimizing. So so we got involved with Trove, got really, and before that, we weren't really an open source company either, which is kind of also a difference in the evolution here. But, as we got involved in the Trove community and in OpenStack, we've since become, and these numbers are a little bit old, but since become the largest contributor. The numbers, if you looked at Stackalytics today, which kind of tracks this thing, we're probably about 35% of the contributions in the current release of Trove. So, made a real commitment to moving this project forward and have gotten really in-depth involved with OpenStack and open source. And I apologize, I've got a bit of a cold, so if I'm coughing on occasion, that's probably, you'll know why. So when you look at the challenge for databases in the cloud today and how they get managed, I mean, everything's changed really. When you look at, I think generally what we find is, databases are one of the harder pieces of infrastructure in the enterprise to manage, and the requirements on them have really changed pretty dramatically in recent years. And and there's this real division between where the developers are coming from and where the traditional ops teams and those guys. And obviously there's a move towards DevOps, but and the model of combining the roles and reforming it in different ways. But I think in general, when you look at what were the goals of these two roles, even if they're combined in the same people, the developer needs to have optimized systems. They want to have the ability to take advantage of new technologies like NoSQL. And there's, again, I've talking to someone recently about the different approaches to NoSQL, and they're kind of laying out like the 7 canonical versions of data structure and storage, and whether it's time series or graph databases or document or key value stores or more traditional relational models. There's a lot of different people have come to realize that there's a lot of different models that can be valuable, and many applications have multiple databases even to take advantage of these new storage capabilities. So again, people aren't satisfied with just the old corporate standard of you have to use Oracle. Also, I think the other thing that's really come around is the need for agility, and the new models of development that the cloud enables create a whole lot more agility. The developers are generally used to using AWS and Amazon. If you go to Amazon, you say, hey, I want an RDS database. In a few minutes, you've got one. Whereas, in the old style, it was, you go to your IT team and you say, hey, I want a new Oracle server, and they do some capacity planning, and they do some, requisitions for buying new hardware, and they set up a replica pair because, you don't want to have any failures. And, it's weeks to months before you've got something provisioned and up going. So I think the challenge here is, for the developers, they really have, different set of needs than what they used to. And, of course, that all puts pressure on the operations team because, they don't have the ability to staff a team that has all those skill sets. They don't have the infrastructure. They don't have the knowledge base of Cassandra and MongoDB. That it's hard enough to know really, databases are really complicated generally in terms of being able to tune them and optimize them and make them really hum when you're operating in production and at scale. And if you're trying to be an expert in Oracle and at the same time Cassandra and at the same time Mongo and at the same time Redis, there's a lot of different skills there and a lot of different capabilities that the team really needs. And at the same time, budgets aren't getting any bigger. As it says, it's the world is not kind of accommodating that. So a lot of times what happens that we see is the Cassandra expert will be somebody on the project team. This is kind of typical DevOps model, and that's a fine approach. The challenge becomes, of course, when that application matures and it's rolled out into production, and that Cassandra expert moves on to the next project. Those skills move with them, and that's creates again a gap. Whereas in the old style world, the centralized team would have those skill sets and would kind of stay with those applications and manage them over time. And this again, I think this is creating a big gap for organizations that need to manage these databases and new styles of data sources over a longer life cycle, but they're not they're kind of faced with a pretty significant challenge, and they need new tools that will allow them to really accommodate that kind of a style. Does that make sense? Great. Yeah. Again, I can't see your faces, so I don't know if you're looking really confused or it's all making sense. But I'll just plow on until you ask a question. So OpenStack again, I won't obsess on it, but I think one of the things I like to say about OpenStack is a lot of people ask me whether it's real and whether people are really using it in production and whether it's capable of production. And yeah, absolutely. I mean, we see a lot of people. We talk to people every day who are putting it in production. And the other thing I like to say about OpenStack and cloud and the cloud in general, people a lot of times they say, the cloud is not being used for production and it's all in dev test and it's kind of a toy box, right? And that just drives me crazy because, I think when you look at the IT and you look at developers and supporting developers and making them productive, that's a really important thing. Right, and the fact that you're using the cloud and OpenStack and database as a service to support development and test, that doesn't mean that it's not useful. And developers are a really valuable part of the team, and making it very easy for them to provision systems quickly, and make them more agile, and make it easy for that the systems that they get are optimized kind of from the start. that's a really important thing. And OpenStack is really trying to enable that, as well as being able to support these kind of big productions apps. But even in cases where it's being used, more earlier stage and in development cycles, I still think it's important to recognize there's a lot of value there. Moving on specifically to Trove, the Trove mission is, to provide a scalable, reliable cloud database as a service. And it's not just relational. Again, a lot of times, when I talk about it, and I'll get to that, too, is, comparing it to AWS RDS. But one thing that's different is it does go, not just relational, but also NoSQL databases. So if you look at, what is Trove? Database as a service for OpenStack, and it is a platform. So it's something that it's an open source platform that people can deploy into their own private clouds. It lets you do self-service provisioning, overall lifecycle management. It gives you SQL and NoSQL databases. It's kind of, again, self-serve for databases. So this is, again, getting into a little bit of a comparison to AWS. And again, I'll trying not to obsess on OpenStack, but I think one of the things that's different, again, kind of usually look at the compare and contrast, because Amazon is kind of the de facto standard for when people think about the cloud and when they think about what are all these database services that are out there. Amazon has several, and they're really great, and they actually do a really good job of supporting their users. And give you a lot of variety there when you compare DynamoDB or SimpleDB on the NoSQL sense, or RDS that provides support for a number of different relational databases, from MySQL to Oracle or SQL Server, or their new Aurora system. And then they've even got Redshift, which is the data warehousing platform based on the ParAccel technology. So they've got a lot of features there, a lot of capabilities there. But I think one thing that's very different is that when you're talking about how do you operate a private cloud, or when maybe it's a public cloud but you're a small cloud service provider and you're trying to deliver a service to your users, you don't have the staff of Amazon. You don't have the scale of Amazon. You don't want to have a separate staff for managing the NoSQL technologies, and a separate staff for the SQL versions, and yet another staff for data warehousing capabilities. Trove really tries to bring that together and give you a common set of APIs, a common set of administrative interfaces, so that you can kind of manage those all in a consistent way. So, and I think another thing, another question we get a lot of times is when people think about database as a service is it just provisioning? And, again, I think if it were really just all about, launching database instances and VMs running, MySQL or SQL Server, you can do that with Chef or Puppet. You can script it up. It's not that it's not that hard. It's again, it's something that you can figure it out, especially if you're only dealing with one or two different styles of databases or something like that. So, but Trove goes well beyond that, and it gives you a number of things. It gives you some capabilities around tuning, in terms of setting up the configuration parameters and things. It sets sane defaults around those in terms of how you set things up. And some of the examples here are kind of MySQL centric, but again, regardless of the technology, there's the ability to take advantage of the different tuning parameters and configuration specifications for the different storage engines, and data stores like MongoDB or Cassandra, what have you. It gives you the ability to do management, in terms of schema management, resizing, managing users, managing schemas over time, and also, it gives you some, kind of control over security, authorization, and authentication type capabilities as well. So it is, again, gives you kind of a full service, kind of one-stop shop for how do you manage things. And it does try to balance Again, I think one of the things that's a challenge and that we try to focus on around Trove is how do you balance, presenting, kind of the best of breed capabilities of all these data stores, at the same time, trying to keep the management API and the operations API more generic and more simplified. And that's, kind of the balance that Trove tries to strike as well. So moving on, so the next thing here is, kind of thinking about, where is Trove actually being used in production, and there's a couple of different places where they have it in public cloud. At HP and Rackspace are both using it in their public cloud implementations of database as a service. Both of those are for specifically from around MySQL, and in fact, that's actually where Trove came from. Is kind of the joint project called Red Dwarf that HP and Rackspace collaborated on, back in the day, and you still see, if you ever go look at the code base of Trove, you'll see a prefix called RD, and that's Red Dwarf. So you'll see that here and there. And another thing is that there's the kind of the single user version of Trove, the trial, if you will, something you guys can easily stand up and play with, is called Red Stack. So that also comes from that heritage. If you look at another place where it's being used is actually at eBay, and they're using it actually across many different databases and data store technologies, from both MySQL, but also some of the NoSQL things like Mongo and Cassandra, Couch, and Redis for those systems. It's actually supporting some of their use cases. We actually have on our website, if you're interested in getting kind of down in the weeds, and I will not say that this is going, you'll definitely be in the OpenStack weeds if you see this presentation, but we had last year, at Trove Day, that we hosted, and we had a number of different guys presenting at that, and the eBay guys did that, and they talked about how they actually were deploying Trove in their cloud and using that to support some of their production websites. Again, key use cases for the technology. The development and test, as I said, important use case. No matter, not a toy, important stuff in terms of making developers more productive. Web application hosting, so that's another thing, when you look at people, and I think these are just, those ones are things that when you look at people adopting cloud, definitely those are kind of trends that people are following there too, because, web applications are usually kind of a bit lower risk. In a lot of cases, although again, I think with eBay that is kind of their core business, so that's kind of not even low risk for them. The other use case that we see is what I described here as on-demand analytics, and that's something that's kind of interesting because this is one where it's a little bit like Hadoop, but it's using maybe more traditional databases, maybe it's Cassandra or MySQL, to run some queries, do some experimentation, test out, load in a bunch of data, launch a bunch of servers, maybe load in a bunch of data, run some queries on them, do some test case analysis, and then throw them all away when you're done. And that that deprovisioning is also kind of a key part of that use case. When you look at the Trove architecture and kind of how Trove fits into things, I think one of the things I always say is when you look at database as a service in general, it's a service that is kind of unique in the ecosystem, I find, because when you look at excuse me, when you look at PaaS platforms or you look at infrastructure as a service, sometimes databases kind of fall somewhere in between. And the reason for that is, I think, is that on the one hand, there's something that definitely are something that kind of sits above some of the basic infrastructure. So in Trove's case, it does take advantage of the underlying compute engine, Nova, which like similar to EC2, it takes advantage of Cinder and Swift in terms of storage management. But but at the same time, it's not databases are generally not an application themselves. They're a part of an application, and they're a piece of infrastructure that supports an application. So, I think one of the things that we find when we're working in these environments is, where does database as a service fit in the overall ecosystem, and how does it, how do our users think about it? Because again, it is kind of a basic building block similar to a compute or a storage component, but kind of it does also depend on those kind of basic those other building blocks as you build things up. So again, I think we spend time talking to both the OpenStack and the infrastructure guys, but we also spend time talking to the Cloud Foundry guys and guys kind of the next tier up, because they always see database as a service as being a component of that piece of the infrastructure as well. Other questions? Am I going about the right speed? Making sense?
I see heads nodding.
Okay, great. Another key thing about the Trove architecture, and this is something that is a little bit unique, and I've kind of alluded to this before, is this idea of multi-data stores and being able to support many different engines and different types of database technologies, and to do that in a way that doesn't make the operator's head explode, right? So that this is something where, and the way that Trove manages that kind of architecturally is by isolating the different parts of the code. So on the one hand, there's a set of code in Trove that is kind of data store agnostic, and it kind of is responsible for presenting a user an interface to the user, whether that's on the dashboard and in a web-based GUI or through the command line or a RESTful API, kind of through direct communication with a controller. And then on the flip side, there's the ability to create specialized code for the underlying databases. So the actual code that you would have to execute to do a backup or to create a replica for MySQL is going to be different than the code that you use to do that with MongoDB, for example. And not only that, there may be cases where based on the way you've configured your environment or based on the requirement that you've set up, you may have different strategies for backup. So, for example, with MySQL, you may say, in some cases, I want to use a strategy whereby I'm doing a MySQL dump to do my backup and just kind of, not do it kind of in a high performance way, so to speak, but just to do, kind of a text ASCII dump of the database. Or I may want to take advantage of ExtraDB backup, the Percona tool, or I may want to use something like, may want to do a snapshot of the volumes or something. So the ability to do those, create different strategies, configure those different strategies, you can do that by parameters, and those are the kind of things that kind of bubble up into the controller. And again, I think, I say, there's the database agnostic components within the controller, but there is the ability to pass through parameters, and you can pass through, for example, there's a ability to set a configuration within a database, but the actual variables and parameters that you pass through there may be database specific. So again, it's not, it's generally trying to create an abstraction, trying to create APIs that allow you to kind of manage things in a consistent way, but at the same time, again, trying not to neuter it so that you can't have access to those lower level functions if you need to, in the case that it really is something you want to manage.
Hey, Ken, I have a question for you.
Sure.
Who's writing the code to attach in those separate databases? Are those communities coming and doing that? Is that something the Trove team is doing? Or do you guys kind of have a line saying this is as far as we go?
Yeah, so it's actually kind of a mix. And, this is kind of a subset of the supported databases as of today. But so, for example, the MySQL, Cassandra, Mongo, Couch, those were all done by the community. So those are all done, by the members of the team. Certainly, eBay was a big contributor because they wanted those databases to be used in their environment. Oracle is something actually that we as Tesora kind of took on and kind of implemented on our own, and the way we did that's a little different. But I'm not. We actually are taking advantage of the Oracle multi-tenant features in order to implement that Oracle guest agent, which kind of puts it in a fairly different architecture frame. That would probably be a longer talk if I went into all the details around how that one all fits together. But
So adding to that, has anyone tried to actually maybe that connection to Oracle? I mean, you guys can open source it, or you guys can charge for it. Has anyone made the play to say, well, if you want to connect to this database, we built another layer of service or something?
yeah, so with Oracle, at Oracle it is part of our product. So the Oracle connection is part of our product where we're doing that. So that's not something that's in the community. The community in general is looking to add things that are actually based on open source databases. So this is kind of one of the lines in the community draws is kind of looking at the things that they support, the things that they bring in and implement are generally the databases that are open source. Versus, basically all the other ones on this page are. So that's kind of the other family of databases. There's another group is actually there are some databases that are actually under implementation right now that are being done by the database vendors themselves. So, for example, IBM right now is working on guest agents, both DB2 and CouchDB. CouchDB is kind of interesting because CouchDB is, as you may or may not know, CouchDB is the database that underlies the Cloudant database as a service offering that IBM acquired a little over a year ago, I think. So now what IBM's found is that actually when people want to implement the database as a service in on OpenStack, what their customers are asking for is Trove. So they want an open source solution. They don't want just the proprietary Cloudant version. So that now what they're doing is they're going out and implementing the guest agent for CouchDB as well. We're also working. Actually, interestingly, our office is across the street from HP Vertica. Those guys are actually now investing in building a guest agent for Vertica as well. So again, it's kind of a combination of us as a vendor implementing for Oracle. There's the community that's bringing on board most of the open source databases. Postgres is now supported. That also came out of the community, and then some of the database vendors are investing in building up the support themselves.
What about Microsoft SQL Server?
Yeah, we that is on our roadmap as Tesora, so we're looking at implementing that. We've actually had some discussions with some other folks who are potentially interested in collaborating with that on that. And again, as with all things community open source, one of the things I'll say is there's things that we're doing kind of on our own and pushing the project forward for our own version. How long things stay in our product alone and how long things and when do things show up in the community version. There will be a continually evolving horizon there, I guess is what I would say there. Whether Oracle will always be just part of our product or whether that'll get back to the community, I expect it'll get back to the community at some point.
Yeah, I haven't seen Microsoft do much other than Hyper-V. So has Microsoft really been working in the database space?
So Microsoft has not been, we haven't been working with Microsoft on this, but there's another company that is working on OpenStack for Microsoft.
Okay.
And I forget. I'm sorry?
They do work, but they don't want anyone to know.
Yeah, exactly.
That way they can say, I didn't actually develop the open source.
I didn't do the open source stuff, but it's there.
It's there, but it's better if you buy my product.
Of course, that's Microsoft. All right, thanks again.
Yeah, there's actually one of the things we found is as we've worked with enterprises that are rolling this out, the one we're getting a lot of people that are very interested in Oracle, because again, a lot of people have Oracle out there. We're also getting a lot of people that are very interested in having Trove work with SQL Server. So more than I would have expected, honestly, but it is it's interesting. We do expect it's going to be Hyper-V. It's going to be something in terms of how we virtualize it, but um, it's it, we're not there yet. I guess I can't tell you too much about what the SQL for Server port's going to really look like.
And you're supposed to divulge. This is friends. Nothing bad. We're in Boise. What are you worried about? No one doesn't exist.
Sure. Yeah. Yeah, it's more just I don't know. So it's not really a secret. But anyway. So the code, another thing just in terms of how Trove actually implements that in terms of code modularity. And so there's the Trove guest agent, which is, and by the way, OpenStack, whether you know it's not, OpenStack's basically all Python. And that's kind of religious or you could describe it as religious or pragmatic, from the OpenStack community. Again, the benefit of having all the code be in one code base that everybody can read and review. I think there's a lot of advantages there. There's some challenges because you don't have the flexibility of taking on new languages for different components. But in any case, here's this is kind of just getting into the Trove architecture. The guest agent, that if you're looking to do a backup, it goes into a particular guest agent strategy for backup and then that backup strategy goes out and looks at that specific base for that backup strategy, and then that goes off and it finds from the strategies it goes out and looks at the either MySQL dump or the backup executable. This is kind of the Percona XGD backup implementation, or the either for the full backup or the incremental backup. So again, this is just kind of the way, just kind of giving you kind of some insight in terms of how the Trove architecture and the code modular kind of plays out, how those, the specialization within guest agent into a specific implementation around MySQL actually shows up in the code. So then into how to actually use OpenStack Trove and how Trove and Database as a Service actually gets rolled out. First as a user, you can download our editions. You can use the HP Helion. It actually includes it in their as part of their distribution. Or you can just, if you're using some other distribution, you can pull our version off of our download and install it. We have both a community edition of our software, which really works kind of in lockstep with the community version. Although we do have some fixes. We actually do a lot of integration testing and kind of cross testing across all the different versions of OpenStack. Whether it's Red Hat or HP or Mirantis's distro, and then across all the databases, so we can validate that. So there may be some bug fixes, but otherwise, generally, that community edition stays in lockstep with what you get from the foundation. As a developer, you can go in and you can clone it. I don't know how many kind of open source developers we've got in the audience. Anybody? One? Okay. Well, for one of you can jump right in and start contributing to the project there. Moving on to kind of how do you actually then go from getting the code, how do you use it? Trove, the command line, what it would look like is just do Trove create. The instance is you're creating the name of an instance that would be something like a MySQL or something. You're specifying flavor ID. Flavor in OpenStack is kind of your machine size, how much memory, how many cores, and then the size being the volume size. How much storage do you want to allocate for your disk drives? And again, I'm kind of in the OpenStack nomenclature of Cinder being, again, block storage, the file system, distributed file system where you're actually storing the databases. But and it does support different availability zones, so you can create replicas across availability zones and things. Actually, I'll get to replicas in a second. Managing databases, you can resize it. As if you are monitoring it and it's hitting capacity, you can resize it. If the disk fills up, you can resize that. Can do create schemas and databases, create users, enable root user. Excuse me. Doing a backup. Again, as I said, it takes advantage of the underlying services, so it does do backups. It takes advantage of the Swift, which is kind of the equivalent of S3, the Amazon's S3s for object storage. So you back up to S3, and if you're doing those, you can do full or incremental backups here. And then to restore a backup, one of the things, just kind of the semantics of Trove, is if you're restoring a backup, you don't create a new and you start with that backup is kind of the way Trove kind of handles that, as opposed to, so that way you're sure to get a fresh instance at the point that you're recreating the instance from backup. Just in terms of the kind of the timeline and things that the things that came out in Juno. Juno was the release that came out in October of last year. So this was kind of the most recent release that's come out. Asynchronous replication and MySQL. So we're still early. The clusters and generally the cluster API and the specific cluster support for MongoDB. That was actually another thing that was contributed by the eBay guys, so they're definitely active participants in the community here. Neutron is the networking layer of OpenStack. So if you want to create a separate network through which you are able to access your data stores, that's how you would get at that. Backups. Tempest is a testing harness to do that. The replication. We talked a little bit about this. So, you can create a replica. It's an asynchronous replication, so a read replica. So for scalability, or to create a replica, you could detach and then just, run queries on kind of a snapshot in time of your database after running the replica and detaching it. Clustering. Clustering is also a very important feature that came out in Juno. And you can create instances. One of the things about the clustering feature of Trove is you can have heterogeneous nodes in the cluster. So with Mongo, for example, there's a config server, there's query routers, and you can define how many of each piece of the architecture you want when you're configuring it. You can also create a set of shards and a set of replicas. So you can say, give me a Mongo cluster with 3 shards and 2 replicas in terms of doing that as well. So there's a lot of, again, the goal is to define, for Trove, the goal is to define kind of a cluster API that could be kind of general purpose and could be reused across different data store technologies and give you kind of a consistency of API, as much as is reasonable here. Next release, and again, OpenStack has.
Hold on.
Yep.
I'm sorry. Ken, is there any automation around resizing clusters?
There's no auto resizing of clusters right now, but that is something that's on the roadmap that we're talking about. But it's not going to be that auto scaling and auto resize. Is not something that's on the docket for Kilo release, which is the next release. But it's something that we'd expect coming up, either in Liberty, which is the next one after that, or beyond.
So just so the next release will be in May?
Next release will be in, so again, the cycle is, the next release is actually April. The next summit is in May, but the release actually shows up kind of a month ahead of that.
What is your expectation around how
operational overhead relates to number of tenants or number of machines under control?
I'm not sure I understand the question.
Imagine an operations team has to support the databases as a service. If somebody was hosting Trove as a service provider,
Yep.
how big of a team would they need, and how does that relate to the number of customers or the sizes of the databases or so on?
Yeah. Yeah. So I would say, again, this is something that, I would say we don't have a ton of data on yet in terms of systems of the scale. I know that when you look at what eBay is doing, eBay has several thousand nodes. They're storing like about 5 different, again, another factor that impacts the number of people you have to have on the team is the types of databases. They've got 5 different types of databases that they're supporting. They're supporting this in production, so there's kind of the 24/7 on-call element of that, and their Trove and they're doing ongoing development and contributing back to the community. Their team, I believe, is 3 people, so it's a fairly modest team to be able to kind of manage all that. And the 24/7 is kind of beepers, but it's still a fairly modest team. Now, when you look at somebody like Rackspace or HP, they have larger teams, but they have kind of public cloud services, and they have customers who are not kind of internal, and I would say. And no disrespect to either of those teams, but the eBay team, they've got some very bright guys in that team. So the three guys are probably, equivalent to a few more than 3 guys. So, but the Rackspace and HTTP teams are probably each about a dozen guys, ish, for say 10,000 servers.
So I would say just one thing on that, Paul, that when it comes to OpenStack and you look at these companies, the community is showing, CERN, eBay, the guys working there are brilliant. I met these guys, they're amazing. One of OpenStack's problems is the big customers we're showing are some of the smartest developers, they're really top-notch guys. We haven't seen OpenStack go yet to kind of I'll make fun of my own company, HP. We haven't gone into kind of the average mainstream kind of IT guys to see these things massive use yet, and that's kind of the next hurdle.
Yeah.
The guys from CERN, I met those guys. They're crazy. McCarty Libre, they're down in Chile. They're bigger than eBay. They do essentially the same thing. They've been running OpenStack in production for a site bigger than eBay since its very first release. There's 3 guys that do the whole thing. I've met them. They're insane, but they're unbelievable. Each one of these guys is worth like 15, 20 people. And so that's a hurdle, I think, for the community. And, we love to talk eBay and stuff like that, but the guys there are unbelievable.
Yeah.
Think of it as from the scale of technology, right? Think about your average, everyday enterprise company. We've got one managed IT company they're paying that's got maybe a fresh out of college, maybe a junior level database admin that knows how to fire up a MySQL instance.
And so that's a problem I think cloud has. How many guys think Amazon has keeping all their cloud up and running? There's hundreds of guys.
Yeah.
Everyone goes, hey, put the cloud up. You just don't put a cloud up. It's it takes an enormous amount of people to do it.
Yeah.
And then adding databases into it to me is insane. It's so complicated. But Paul's a bringer. I brought him in. This is from Oracle. Can't just to screw him.
Also from AWS.
All right, Ken.
I would say, definitely agree with you in terms of the kind of level of guys that are kind of on some of these OpenStack projects. But one of the things I'd say is that if you look at, kind of the administration on kind of the public cloud side on Rackspace or HP, those teams are, they've had turnover because those guys have moved. The more senior guys, like some of the guys that we started working with on some of those teams, have moved on to other projects, and so kind of the day-to-day operations on some of those teams is it's not it's not quite the same rocket scientists that were maybe there a year or two ago.
Okay, but I just know at HP's Public Cloud, we haven't hit the volume.
Yeah,
It's not
absolutely.
It's going to make anyone pull their hair out.
Yeah.
Why we don't talk about it anymore.
Yeah, there you go.
Okay, Ken, sorry.
Yep. So kind of looking forward, what's in Kilo, which is again it's the April release, is one of the things I think is kind of the big thing is around the asynchronous replication and V2, which basically gives you the ability to do failover. So again, the version that's out there now, actually in our enterprise edition that we released this support for failover early, so you can get that if you download our enterprise version. You can get that now, but that's going to roll out into the community in the Kilo release. So previously, again, the replication that was there before for MySQL was really just for read replicas, and now this will actually let you do failovers because we're tracking GTID as global transaction ID. So it's and that will also, once you have that, you're also going to be able to do multi-region, because you can control the regions that your systems are set up in. So that's another capability that comes through there. So just quick commercial. Who am I? This I kind of already talked about in terms of the Trove contributors and everything. What do we do? Try to make it easy, make it robust. Provide support. And try to bring in more features, both in terms of things like Oracle, bringing those forward quickly. Having a release cycle, so give early access to features like the replication and failover type stuff as well. But that's kind of who we are. And then if you want to get more information on Trove, so you can go to the wiki, you can get the source, you can get installable packages from us. Jump on the IRC, and there you go. We also have a LinkedIn group. I mentioned earlier, Trove Days here listed. I mentioned earlier the eBay presentation, so there's the video of that presentation is up on Trove Day, along with HP's. HP also talked about their implementation and a number of other topics, that some that even go beyond Trove, so you can have a look at that as well. So that's mostly it for me. So I don't know if I went over. I think I probably went over what I was hoping to do, but.
Everyone is still here looking. Does anyone have any questions for Ken? Yeah, go ahead.
Hi, Ken. My name is Michael Durant. I have a question about the strategies for high availability replication. Is there I don't know what you'd call it, a higher level of abstraction that from, for example, when creating a cluster of database to, well, I want this cluster to be a publisher-subscriber setup. Here's how many publishers I want, how many subscribers I want. Is there anything like that?
So how many publishers, how many subscribers? So so you can create as many replicas of a given master as you'd like. Currently within Trove, so again, this becomes a little bit data store specific. So within MongoDB, for example, in the clustering support, you can say, I want this many shards, which is kind of how you're going to distribute your data. And those are all effectively masters, but for different slices of your data set. You can then say, I want this many replicas, so you'll get some set of replicas for each of those slices. And they're not necessarily aligned 100%, but you're kind of getting a similar capability to what you're describing. In MySQL, you can do these read replicas, that you can create as many read replicas as you'd like. You can chain the read replicas, so you could say, I'll take a replica and I set them, of the master, and then you can take a replica of that replica. Now, of course, there's replication lag, and it gets exaggerated as you move further and further away from the central source. Currently, in MySQL, there's unfortunately the implementation of MySQL clusters, which would give you kind of the multi-master, is not there yet. So that's something that's actually being worked on now in terms of supporting the multi-masters using kind of more of a synchronous replication model. But that would be kind of the way I would expect you would have I want this many masters and this many read slaves. Did that answer your question, or was I going off in the wrong direction?
Well, I was thinking of a higher level abstraction where it doesn't matter what the implementation of the database is on the background, that we have these higher level ideas as far as database, high availability strategies, just being able to apply those strategies to a Trove database set without having to worry about what it is on the back end.
Yeah. So that definitely makes sense. Right now, the interfaces and the APIs are more at a technical abstraction and less at a kind of a business requirement abstraction. We've actually also had some discussions about how do we kind of change that language and move it to a more business level language. That's actually one of the conversations we've been having actually with Oracle, because Oracle, the enterprise manager team, would like to come up with a kind of industry standard terminology around. You kind of want to define business rules around qualities of service, number of replicas of the data, the amount of kind of the availability by some kind of business metric, right? How much downtime can you tolerate, for example? But right now Trove is not. The Trove APIs don't present it in that way.
How hardened are the guest agents for security and compliance?
Yeah. So they are. The objective is to have them is for them to be hardened, and there's a number of different ways to specify them. They actually are communicating. For example, they actually communicate over message bus. You can kind of isolate the traffic along the message bus to a particular tenant or to a particular agent. You can encrypt all the traffic in and out of the box. You can disable SSH. You can disable any access to the box other than through kind of the known ports through either the messaging port, which is kind of where your management commands are coming through, and then through the database query portal, which is basically the connection string that gets sent back to the client who actually provisioned the database. Under the database itself right now, you provision that guest image. There's a guest image I didn't really talk about, but it's kind of your virtual machine image that includes both the database server generally and then the guest agent there. When you launch that image, that's kind of hardened in that way, but that's kind of where that's set up. One of the things is that the guest agent itself is never kind of set in between the access to the database through the query or the access or the update interface. So the connection string that gets passed back when you provision a database is connecting directly to the database server on that host. It's not connecting through that guest agent. The guest agent is only involved in kind of the administrative activity.
Any other questions for Ken?
I didn't have one.
Yeah.
I'm the guy that asked about your car, but I won't ask about your car this time. But can you explain your business model and in terms of, do you have data centers, data center yourself? Do you actually, or do you use somebody else's? How do you get customers in the door?
How do we get money? Yeah.
That?
Near and dear to my heart. Yeah, so our business model, we're actually not a service provider. We're actually a software company, and we think of ourselves as a software company and not as an operator of the service. So what we do is we have kind of an open core model where we basically have our enterprise version that we sell and that we support, and that includes the Oracle support, as I mentioned before, as one of the capabilities that's part of that. We also have our guest images, which are these pre-canned images, pre-canned virtual machine images that contain the guest agents and the database servers, and that's also part of the proprietary piece that we're distributing as part of our product.
Trove from the community, but if you're doing enterprise and you do more advanced things, they will always be two steps ahead.
Yeah, I thought that's what they did, but I also thought they were providing.
Well, they give some back to the community, but not everything. It's just like HP, right?
No, what I
what
meant was but I thought they would actually sort of sold that.
Oh, the
What
operation.
they did as an operation.
Like Rackspace.
Yeah, they're not exactly.
It's not database as a service, it's software that allows you
To provide it as a service, yes.
That's right.
Well, Ken, I appreciate you doing this. I know it was hard, but we got great questions. This was there's some heavy hitter database people here in Boise.
You know what, can I throw out one more question to you?
Yeah.
Sure.
How do you think your business would be different if there wasn't an open source component to it and it was suddenly closed source?
I think, so how would my business be different if everything was suddenly closed source? It would be both simpler and more complex. And in a way, one of the things I would say is that when you look at the enterprise today, the move towards, if there was no open source in existence for anything, we would be back in the old world of, enterprise software sales, and that's in a lot of ways easier, right? Because, you own your own IP, you control your own IP, and you're just selling, what you have, and you have a lot more control over your own destiny. I think that, there's in the world of, but the problem is that world doesn't exist anymore. Enterprises expect to be able to have access to code. They expect, they think of open source as, I'm going to get a little philosophical here, but, I think open source is one of those things where, people kind of expect it as kind of the standard model for public escrow. It's people want to have, if a large enterprise is adopting software from a startup, they're going to want to be able to know that, they're not on the hook, they're not stuck, they're not kind of trapped by this closed source proprietary solution. So open source really takes away a lot of that risk that maybe in the olden days that those guys would be taking on. So I think really when you look at the level of expectation, what the enterprise are expecting when they're getting software these days, it's very hard to convince an enterprise that they should take proprietary software for their infrastructure. It's just it's just open source has just so many benefits to them over that at this point. Now, that said, it's certainly because they don't want the lock-in, right? They don't want the lock-in. So from a vendor's perspective, lock-in is awesome, right? Oracle loves it. Talk to Oracle about how awesome lock-in is in a business model. But and I think from that perspective, you can see why that would simplify the business. But again, I think as a startup, it's great to have the ability to sell something and kind of de-risk the solution for the enterprise. There's also again I kind of underestimate it or maybe undersell it, but it's great to have the contributions from the eBays and the and HP and the other participants in the Trove community. But honestly, if you can just focus on developing a software product, um, in a lot of ways, you can probably build it as fast on your own as you could in the community, if not faster. Because there's a lot of politics, there's a lot of complications in terms of collaborating with a larger group. You get a better solution. Again, working with people who are operating in cloud day to day and collaborating with them, you get the benefit of their experience in working together with them. But it's not without its challenges in terms of just moving the thing forward. So in terms of actually how many lines of code do you generate on a day, even though we're only a third of the commits to the project or something, maybe a little bit more than that at this point, we could probably be writing a lot more code if we weren't kind of in the community in that sense. But I think it's the much more impactful thing is, again, how enterprises adopt technology and how they feel, how they deal with the risk and how they deal with the a company like ours. Does that make sense, or or was I rambling too much?
Thank you, Ken. You did good. And Ken, I have to tell you, I did not expect this heavy-duty database attack on you tonight. So this was fantastic.
That's great.
This is payback for what your Twitter person's been doing at HP, making fun of our Helion rack announcement. But I have to speak on that. But other than that, you've picked one article out of 50 to continually retweet, and I'm getting yelled at by my bosses, so we have to speak.
Oh, come on. We're usually nice to you guys.
Yeah, not on this tweet.
Uh-oh.
So, anyway, Ken, thanks very much for doing this tonight, and we certainly appreciate it. And the next time you're out, and don't do a full flyover, stop in Boise, Seattle or something, and come in and visit. We'd certainly welcome you here for sure.
I'll parachute down on my way through.
Well, it's kind of a DB Cooper, right? Whatever. So, but we won't steal any money. But thanks again, Ken. And if you can get me a copy of this recording, that would be awesome.
Yeah, we'll do. And also, if anyone has any further questions, feel free. The email's there. You can ping me, and happy to follow up on anything if you'd like.
Thank you.
Thanks for having me.